Okay, so we're going to take a look at solving systems of linear equations. I want to do more practice on this. So just focusing on substitution and elimination, we can choose whatever method we think works the best, and we can go ahead and solve it. So let's take a look here at example number 1. So if I'm going to solve this one here, I see both elimination and substitution as options. Let's take a look at how you'd solve this using elimination. If I rewrite this, and again, I encourage you guys, pause the video, try the question out yourself, and then see the solution. Okay, so if I do this using elimination, I'm already in a situation where I've got the ones the same in front of the x's, so I can subtract these equations, and you take care of this column-wise. So the x's cancel, you get 0x, negative 15y minus positive 3y is negative 18y, and then here we get 3 minus 21 is negative 18, so negative 18y is negative 18, so y is 1. I got my y value is 1, and therefore I can sub it into either equation. I'm going to sub it into 1, so x minus 15 times 1 is 3, x is 15 plus 3, x is 18. All right, so I'm getting here, the point of intersection is 18 and 1. All right, again, pause the video, try this question out yourself, and then see how you did. Okay, the first step with this question is you need to rewrite it so it's in proper order, alphabetical, the x's, the y's, the equal sign, the number, right? Because that's the easiest way to see sort of what you have. And if I do that here, rearranging this, you'll notice I brought the minus 3y to the left-hand side and then subtracted 9y on both sides to kind of isolate. So now I'm in a situation here. This wouldn't be a good substitution question because I can't really divide out to get a coefficient of 1. So this would be an elimination question, in which case I'm going to take the second equation and double everything. If I double everything, this becomes 8x plus 6y is 6, and this is like my equation 2 star. So now if you take equation 1 and then I take equation 2, take that, rid of that, I can go ahead and do elimination on this just by going through the operation of subtraction. So the 8x's will cancel and I'll be left with minus 15y, right? And again, how I got that was negative 9y minus positive 6y is your negative 15y, and then 41 minus 6 is going to be 35. Now if I divide out the 35 and the 15 here, divide across by 15, and then we can go ahead and reduce here, so I can divide top and bottom by 5. I get negative 7 over 3. So sometimes you do get that, and sometimes you do get fractions. In this case here, we get negative 7 over 3. Now that I have my y value, I'm going to sub that in and solve for my x value here. I'm going to sub it into equation 1. So we're going to get 41 plus 9 times negative 7 over 3 equals 8x. So it'll be 41 plus, that'll reduce to become a 3, so this will end up being a negative 21 is 8x, and this becomes 20 is 8x, divide across by 8, and you end up getting 20 over 8, which reduces, I can divide top and bottom by 4, and we get 5/2 for the second point. So I'm getting here my point of intersection for this question is 5 over 2 and negative 7 over 3. All right, were you able to get that? Again, if not, don't be discouraged. There's a lot of issues here with the fractions. Can definitely throw you off here. All right, again, pause the video and try this question. Now, if I were to answer this one here, I'm noticing right away, like I'm seeing the coefficients are all the same here. You could do some inspection and see what you have. if you recall, we discussed that the slope of this line is negative a over b, in which case this would be negative 3 over 2, and likewise the slope of this line is going to also be negative 3 over 2. So both of these equations have the same slope. So now we're down to the situation that, and again, I'll link the video if you've forgotten in the top right-hand corner if you forget the types of solutions you can have. But I'm in a situation right now where a unique solution is impossible, right? There's no way you can have a unique solution. That's not a possibility for this question. So there's only two other options. Either we have infinite solution, or the other possibility that we have is no solution. And that's going to be dependent on the y-intercept. So if I do a quick check here, let's take a look here. If I go to equation 1, if I want to find the y-intercept, I can let x equal 0. If I let x equal 0 here, you get 3y equals negative 1. So the y-intercept for my first equation is minus a third. For equation 2, if I go to find my y-intercept, you let x equal to 0, you get 3y is 4, so y is 4/3. So you'll notice here, these have different y-intercepts. So because we have different y-intercepts, I now know that it's not the same equation. Since it's not the same equation, it can't be infinite solution, and we would be left with no solution. Okay, so the answer to this question is there is no answer. There's no solution. These do not have a point of intersection. Okay, take a look at example 4. So one thing you want to do with this example here is you want to be able to clean everything up. So with an equation like this, I'm going to multiply across by 4 to get rid of all the fractions. So now I'm going to rewrite my equation. If I multiply across by 4, you get x plus 2y is 32. And equation 2 is 2x minus y is 14. Now I'm going to solve this using substitution. So what I'm going to do here is I'm going to isolate for x in equation 1, in which case I get 32 minus 2y, isolating for x in 1. And then I'm going to sub x into equation 2. So everywhere I see an x, I'm going to change that to 32 minus 2y. And we get here, now just a matter of distributing, so 64 minus 4y minus y is 14. Okay, let's go over here. So we end up getting here negative 5y equals 14 minus 64. You get your negative 50. So I'm getting here y is 10 for my y value, and then you can sub it in to find your x here. So if I want to find my x value, again, you can sub it into your isolated equation. So now, let's kind of make some room here. Therefore, my x value is going to equal 32 minus 2 times 10. And x will be 32 minus 20, in which case we get x is 12. So yeah, you have an x value of 12. So my point of intersection here is 12 and 10. And that becomes our point of intersection. Again, pause the video, try this one out. So if I were to answer this one here, you can do elimination, you can do substitution. I'll do substitution again, so I'm going to isolate for y in equation 1, in which case I get y is negative 2x plus 3. And then what I'm going to do is I'm going to sub y into my other equation. So now we have 3x plus, it's not a y anymore. And then we can go ahead and solve this, right? Do your distribution. And we get negative x plus 6 is 5. So I'm getting here x is 1. Once you find your x value, you can go ahead and find your y. So I can sub that into either equation. I'm going to go ahead and use my equation here. So I get y equals negative 2 times 1 plus 3. And my y value comes out to be a 1 here. So putting this all together, the point of intersection here. Again, it goes by alphabetical order. You'll see sometimes they'll use A's and B's or M and N's. It always goes by alphabetical order when you're listing your points. In this case, X obviously comes before Y, so it goes XY. And it didn't matter in this case because they're both ones, but in general. All right, there's example 5. Okay, now taking a look at example 6 here. Again, let's, what I would do is rewrite this. So we're gonna have here m minus 3n is 11, and equation 2 is 2m plus 10n equals 6. Again, you should always look to see whether you can reduce, and I can see right away in equation 2 I can divide across by 2, giving me m plus 5n is 3. Let's label that 2 star here. So now if we take a look, I got equation 1, and I've got my sort of adjusted equation 2, and you can see here this is perfect setup for elimination. I can subtract these two. The m's will cancel. I'll be left with negative 8n equals 8, in which case n is negative 1. And then I can sub that into either equation and solve for m. So in this case here, you get m minus 3 times negative 1 is 11. M plus 3 is 11. And m is 8. So again, when you label your points, you label them alphabetically. So in this case here, my point of intersection is going to be m, which is 8, and negative 1. All right, let's try one more here. So for this question here, same idea. I would get rid of the fraction. That's a really good practice in general. So I'm going to take this equation and multiply across by 4. Likewise, I'll multiply across by 4. So my new equation will be 4x minus 3y is negative 16. And also adjust my second equation, in which case we get 4x plus y is 0. Now, setup for elimination is really easy. I can do subtraction. That cancels off my x's here. And I end up getting negative 4y equals negative 16. So I get y is 4. And if y is 4, we can sub that in and solve for x, in which case I get x minus, I'll just use the first equation. These cancel, and you get x minus 3 is negative 4. I get x is 1. So my point of intersection is 1 and 4. All right, so there you go. There's another example here, and that kind of covers the idea of solving systems of linear equations algebraically using either substitution or elimination. Thank you.